Good morning, my name is Luisa Fernanda Camacho Mecha, and in this video I am going to explain the Baghouses design. The bag filters consist of a series of rows of fabric bags in the form of round tubes. The separation of solid is carried out by passing the air with suspended particles through the fabric, forming the bag by means of a fan. In this way, the particles are retained between the interstices of the cloth, forming a filter cake, and the clean gas flows through the outer space of the bags and is carried through a series of ducts to the exhaust duct or chimney. For the design, I will base ourselves on a sample application that can be seen on the screen. Now, two things will be assumed for this exercise. The first is that the gas behaves like air, and the second that fiberglass is chosen. Let's start the calculation with the inlet flow. So, the inlet flow rate is equal to the gas flow rate, o sea, 110 cubic meters per second, multiplied by the temperature deviation, resulting in a flow rate of 58.6 cubic meters per second. Then we calculate the particle concentration. The concentration of the particles for this condition is equal to the concentration of particles number 1, 2.6 grams per cubic meter, multiplied by the division of flow rates, which results in a concentration of 4.9 grams per meter cubic. Area of the cloth. For a filtration velocity of 0.013 meters per second, the area of the cloth is equal to the inlet flow divided by the filtration velocity, resulting in an area 4,508 square meters. And the multiplication factor in table 4 for that amount of fabric is 1.11. Therefore, the total area is 5,004 square meters. For the area of a bag with a diameter of 0.3 meters and a length of 8.2 meters is 7.8 square meters. For the number of bags, the total area is divided into the area of the bag, which results in 640 bags. Number of compartments. According to Table 2, a reasonable design can use 10 compartments, so the number of bags per compartment is 64 in a 8x8 arrangement. The number of compartments in operation is obtained by dividing the total number of compartments by the multiplying factor from Table 4, that is 1.11. Which means that while the filtration is carried out in 9 compartments, one is in cleaning or in reserve. The duration of the filtration time depends on the maximum pressure drop allowed in the bag filter. Assuming in this case that the pressure drop allowed is 255 millimeters of water for the bag filter and the pressure drop in the compartment is 36.71 millimeters of water. The resistance factors for this bag filter are K1 and K2 as seen on the screen. Substituting the data in the equation, the filtration time is 12 minutes, that is 720 seconds, which means the compartment needs to be cleaned every 12 minutes. And the filtration sequence is that 9 compartments begin to function and every 8 seconds one is taken off of operation and the reserve compartment or the one that was cleaned begins to operate. And in this way the filter was designed. Thanks for the attention.